Hello my dear students, how are you all? Welcome back to Diksha Karnataka YouTube channel. I hope all of you are doing very good. Okay, so what's going on right now? We are continuing with our series 60 out of 16 KCET mathematics in 100 days. Okay, so we have completed our previous chapter, which was, I think, application of integrals. We did it in 3 parts. First 2 was concepts part with the questions, and last session I did only for the questions. Okay, so just for the practice of sake, and I think we solved almost 25 to 30 sums in that 3 sessions. Okay, some was very difficult, some was easier category, some was in a moderate category. So we have taken all type of questions and we have solved them in the class. All the detailed solutions are given in my session, so please go ahead and watch it if you have not watched it. The weightage of the previous chapter was how much? Only 2 marks, but still it matters because you already done the integration, so why to lose marks, after putting so much of effort in integration. So simple concepts, learn it. Some graphs you have to remember. I have explained you the graphs as well in the important functions category, and given you questions on that and solve them as well. So please make sure that you watch that video. Okay, now I want to ask you how are you all doing? So what's going on? Okay, because times are coming, times for the exams is coming close for us. So I want to ask you, I want to check up on you that how are you actually doing, bachas? Okay, please let me know. Okay, any jitters, any confusion, any nervousness? It should not be. Okay, because as you can see, I am completing my portions as promised. As I promised you day 1, I'll be dedicated. I'll come up with the sessions every day. So I hope you are also maintaining the same intensity. Please do not lose that intensity, bacha. Okay, it's very important to have the same mindset, same intensity, whatever hurdles comes across our preparation time. But we have to, sometimes we might get sick, there might be a festival, okay, or sometimes we don't feel like studying, sometimes the subject is hard. Okay, for all these hurdles that you have, okay, you have to overcome it, because you have a big goal in your life, right? For that to achieve, for you to achieve that goal, you need to have that mindset of a winner. You cannot just give up like that. Okay, if you are having difficult time while doing all of this, it's okay, it's all right to not feel like studying, but you have to do it. There's no excuse for hard work, bacha. I hope you'll be motivated. Any other questions you have, please let me know. Okay, I will answer to your questions if there is any. I want you to be very up with your intensity and keep doing good work, because just watching the sessions will not be enough for you to crack the examination, okay, that you're looking to do. You have to practice all the questions at the same time. You have to do revision of all the concepts again and again. Okay, whatever the high weightage chapter are there, you have to be knowing all of that. You have to be structured in your preparation. You should know what is the portion which is cut off of the entire examination syllabus. So you should know the syllabus, pattern, your blueprint, everything should be discussed. Okay, everything should be clear to you, and then you should keep revising the concepts, keep solving the problems according to the weightage category. Okay, so I hope you are all doing this. I'm not saying that you are not doing it. I'm really hoping that you are doing this, because I want some good results from you guys. Okay, so for that reason, let's begin with a new chapter today. What is it? Differential equation. Another good chapter from the calculus section. Okay, we are about to close this calculus from PU2 portions. So last chapter of the calculus, let's do it with the same intensity that we have done the other chapters as well. Again, I'm going to solve some questions in the session. Again, I have planned, I think, 12 questions today with some concepts. So we'll talk about in the session about the definition of the differential equation. Means for what type of equation we can call it to be a differential equation. Okay, different types of differential equation we'll also talk about, and we'll talk about the definition part, like what is the order, what is degree, and how to find the solution of a differential equation. So we'll talk about all of this. As I said, different definition of the differential equations, some terms related to it, and then we'll talk about solving a differential equation. It's an equation, right? So we have to solve it to find the values of the variables. Okay, so we'll see that in the session only. So please be with me. If you need to have a break after some time, let's say after 10-15 minutes, take the break right now. Go have some water, then come back and watch the video in one go. It's not just like what you call watching a movie that you finish. You can watch a half right now and watching later. It's a learning session, right? So you must complete what you started. So if you started to watch this session, please finish it. Okay, please solve all the questions, because I want you to benefit from it. If you're giving your time to me, your valuable time to me, because in the short time that you have, every minute that you are giving to anyone should be very, very what you call courteous towards you. That okay, this guy, even though he's very busy, he's talking to me. So if you are coming here and watching my videos in this crunch of time that you are going through, I'm very thankful for that. Okay, so if you're watching the session, please make sure that you benefit from it. Please make sure that you are learning something from here. Okay, if anything you want me to change, you want to ask something from me, please let me know. Okay, because I really want to help you over here. Okay, so starting with the first thing, as I said, the definition of the differential equation will come. So what is a differential equation? First thing, sir, equation is the majority, like thing that I understand from this two words, differential equation. I know you understand differential part also. We learned about differential part in the differential calculus, which was differentiation. Okay, differentiability, these two words you remember. So differentiability means something has to do with the differentiation, obviously, right? The derivative will be there. So equation which contains derivative, can you accept that part? A equation which contains derivative will be called as differential equation. All right, what type of so again, if there is an equation, you'll have what variables involved in it. Means you'll have what type of variables? You'll have independent and dependent variables. Okay, so if I have to summarize all of this, the variables and the equation statement or the differentiation statement, so I can say this like that, that if there is a equation which consists of differentiations or derivative of what? Of a dependent variable with respect to independent variable. Please understand this. Derivative of a dependent variable with respect to an independent variable, then such equations will be called as differential equation. I'll repeat myself. Very important to know this. A equation which consists of derivative, it should have derivative in it, but derivative of what? Of dependent variable with respect to independent variable. So what is the meaning of this? Remember the equation y equals to mx plus c, the simplest equation that you have learned, slope-intercept form of the line, y equals to mx plus c, or y equals to x. Basically, what is the subject here? Subject is y, let's say. Okay, then y becomes a dependent variable, x becomes an independent variable. So basically, derivative of y with respect to derivative of x. Sir, it's the same thing that we learned so far. Why complicating it? I'm not complicating it. That's what it is. Yes, whatever we've learned so far in the derivative, no, same thing is written in this form here. Have a look. What's written here, bacha? It's written like derivative of dependent variable with respect to independent variable. Okay, so an equation which consists this will be called as differential equation. Okay, now there is a category. What is it? Ordinary differential equation. So whenever you have only one independent variable involved, such type of equation will be called as what do you call? Ordinary differential equation. Have a look. X dy by dx dy square by dx square. Okay, so whether the differential equation has second order derivative or the first order derivative, but it should have only one independent variable. When that statement is satisfied, we'll call that particular differential equation to be ordinary differential equation. Okay, simple, nothing much is there over here. Simple definitions. Okay, we'll quickly do them and move on. Achha, one more thing I want to tell you. Let's take this example only, just for consideration. There is something called as order and degree. I know you must have heard about these, okay, because you are dealing with equations for for a long time, polynomial equations for a long time. So order and degree. Okay, for differential equation also we have the same thing. The concept remains almost the same. Order will be related with the order of derivative. Okay, order will be related with order of derivative. Order of derivative. What type of order, sir? Highest order. What is it? The maximum order of derivative. Means the highest. What is it? Tell me here. Case, sir, first derivative is there, dy by dx. There is second derivative, sir. So order can be simply written as 2. Order is simply, sir, 2. What about degree? Degree is the power. Degree is the power of highest order. Degree is what, bacha? Power of highest, or I can write here simply written as, because I've used the term max, so I'll write it as max order. Okay, max and highest have the same meaning. So maximum order of derivative means whatever was the maximum order of the derivative, the power of that, doesn't matter whether it is less or more, we'll see in the coming questions, that will become the degree value. So in this particular case, what's the power of this whole thing? Please have a look. It's 1, bacha. It's 1. So degree will be what? degree will be, it's not visible, I'll use a different ink. Okay, so this whole thing, power is simply 1, so degree will be simply 1. Degree will be simply 1. I hope this is clear. Okay, so order is what? I'll repeat myself. Order is what? The maximum order of the derivative. Maximum order. Basically, first order, second order derivative is there, no? So third order derivative. So third time you have to do the differentiation. That part we're talking about with respect to order definition. For degree, we have what? Power of the maximum order that we have. Okay, let's see the definition. So order of a differential equation is the order of the highest order. Sir, order coming together. That's what it means, no? Means the highest order derivative, if you take, that order will be given as simply order of the differential equation. Okay, we'll see multiple examples. We'll solve the questions also on this. What about degree, sir? What about degree, sir? So degree, bacha, will be very simple. The power, same thing I explained. I wanted to you have this in in notes also. Highest order, so power of the highest order will be given what? As the degree of the differential equation. Okay, differential equation. Achha, one more thing, think about it. Can these two numbers be a negative number? Can this order or degree be a negative number? Can it be a fraction also? Okay, no. Can it be decimal also? No, it will always be a natural number. Okay, non-zero integer you can also write. Non-zero or positive integer you can write. Okay, so it will be a positive integer is what? Natural number. 1, 2, 1, 2. All the counting numbers. So it will be a natural number for both order and degree. I hope you understand that. Yes, great. Now, moving on. So you will not have the power or the degree, sorry, order or the degree as a negative or a fraction. That is reasonable to understand this, no problem over there. Moving on, few notes, let's see what is it. So first one, order and degree if defined of a differential equation, same thing I've written here, right? Will always be a positive integer, bacha, right, na? Right? So it will be what? Simple natural number. Positive integer is what? Natural number. Okay, I hope you have joined the WhatsApp channel, right? Because the notes, just watching videos are not enough, right? So please join the WhatsApp channel. The link is given in all the videos description. Join the channel, get the PDFs of the sessions, and so practice the questions again. This is serious, non-negotiable. You have to do it. Okay, so join the WhatsApp channel, get all the sessions PDF, because why I'm putting effort, okay, over here to make a change in your life. If you're watching the session, make use of it, get all the benefits that you can from the sessions, from the series that we are coming up, okay, with. So the degree of differential equation which is not a polynomial, second note, sorry, I got lost there. A degree of a differential equation which is not a polynomial. Now see this, very, very important. Forget about the degree right now. See the statement, polynomial equation in derivative. What's the meaning of polynomial equation in derivative? Polynomial equation is what? Either linear, quadratic, cubic, correct, na? It means if I have, let's say, dy by dx written here, just like this. What type of equation is this? Sorry, equation is this. It's a linear polynomial equation. I can put a square over here. It's quadratic, put a cube over here. Cubic means if a given polynomial equation in what? In the derivative, okay, is not a polynomial, means it's not a polynomial, means if it is not in this form, okay, not in this form, means this is polynomial, no? Check here, power is there, variable is there, constant is there, not a polynomial equation. In that case, what we're going to do, we cannot take this to be, means degree will not be defined. We'll say simply that degree is not defined. Degree is not defined. Okay, so for that condition, the degree of the differential equation will not be defined. I hope this is clear. Okay, the derivatives are denoted, the notions I think you know already. The dy by dx, d square by dx square, you can keep going like that, or y dash, y double dash, y triple dash, or y1, y2, y3. These are the ways to represent derivative. I've already done this in differentiations, okay, but why this is written over here? Because I'm going to use it in the question solving, because I have to deal with y2, so I will not write all the time d square y by dx square. Okay, for that reason, understand this. Same thing means what? This means it is y dash, also y1. This means what? What does it mean? Second one means y double dash or y2. Okay, any problem? Okay, let me just erase this part, not relevant. Okay, so okay, so degree is not defined. When it's not defined, bacha? So degree is not defined when it is, give me a second. Degree is not defined when it is not a polynomial, but in this case I've taken the polynomial equation. No, that's why I've just erased that part just to avoid that confusion. Okay, it's a polynomial equation. Degree is 3. Yes, degree is 3. No, please see this. Degree is what? 3. Highest order is what? 1. Yes, order is what, bacha? Order is 1, sir. Highest derivative, only first derivative is there, so order is 1 and degree is 3. But if it is not a polynomial equation, we can in the derivative we can't write the degree because degree is undefined in that particular case. Moving on, the first problem that we have. Okay, write the degree of the differential equation. Okay, degree is what? Degree is what? Degree is the power of highest order. Highest order is what? What is this order here? Order is 1. Order is 1. What is order here? Order is 2. But the highest power is over here. We are not bothered about highest power. Please don't write degree as 4. Your answer will be incorrect. Okay, degree is what? The power. I did not say highest power, I said power of highest order. Okay, so highest order is where? In this case, what is the power over here? Nothing, sir. So 1. I hope you understood this. Degree is power of highest order of derivative, not the highest power of derivative. Difference is there. Okay, degree is power of highest order derivative. Okay, and second statement, highest power of derivative. Okay, this is incorrect, bacha. This is completely wrong. Okay, highest power of derivative is wrong. Power of highest derivative. Okay, so highest derivative is what? Order is what, bacha? 2. In this case, what will my answer be? My answer will simply become 2. My answer will simply become 2. So my degree is 2. No doubt whatsoever, right? Very simple. Just remember the statement. Very, very important. Okay, power of highest order derivative. Moving on to question number 2. Find the degree of the differential equation. What about this? The square it up looks difficult right now because it is having the square root. Can you find square root over here? You can't, but you can always square on the both sides. So if you do that, what are you gonna get? If you do squaring both sides, okay, you're gonna get 1 plus dy by dx the whole square, because if you square on the left hand side, it will become what? Simply this term. What will be RHS? Sir, x square. Correct, na? If you square the both side, this is the result. So now if you bring everything on one side, what are you gonna get? 1 plus dy by dx the whole square minus x square equals to 0. What are they asking? Degree, sir. What's the degree? There is only one term, so no confusion over here. Degree is 2. Highest power is how much? 2. Degree is 2. My final answer. Yes, simple enough. Moving on. Okay, so question number 3. The order and degree respectively of the differential equation given like this. Okay, so order I can write. What's the order? Highest power of the derivative. Highest order derivative is what? 2. So order is 2. What about degree? Undefined, sir. Degree is undefined. How come, sir? Check here. Cos is operating on the variable. If it was just dy by dx, it will become a polynomial equation. Yes, if it was just dy by dx, it will become a polynomial equation, but it is cos of dy by dx. It means it is a trigonometric function also present in it. So because of this trigonometric part, I cannot say this is a polynomial equation. So now anymore, this is not a polynomial equation anymore. For that reason, undefined. Degree is undefined. So option number A. So I can write it D and E does not exist. Degree does not exist. So undefined. 2, undefined. Option number A. No confusion so far. Moving on. Question number. Okay. Moving on to the next concept, which is general and particular solution. First of all, understand what is the solution of the differential equation. So solution of differential equation is what, bacha? So I hope you understand by now. Differential equation is the equation which will have derivative in it. Correct? Which will have a differentiation, whether it is first order dy by dx or d square y by dx square. It will have these type of terms, okay, in the polynomial form. So this kind of equations will be what will be called as differential equation. This part is clear. What about solution? So solution will have no derivative. Means from the given differential equation like this, you'll have to reach a point where this equation becomes free of the derivative. I know the answer will be in your mind by now. Think about it. I'm saying that from this given, this is a differential equation, right? Say dy by dx is there, okay? This is a differential equation, but from the differential equation, you have to reach to a point where it is free of the differential equation. What should only exist? The functions and variables and independent variable. So only a relation between variables should exist, okay, and not containing derivative. Means derivative should be out, okay. Only the relation between variables should exist. Relation can be trigonometric. We cannot just seek always polynomial, okay. For the polynomial, don't get confused. Whenever it's not a polynomial differential equation, we'll say what is it? It will not have a degree. Okay, it will not have a degree. So that's the limits of that part. Okay, it can be having a cos also, no problem there. Let's move on and solve this. How will you solve this part? So I can take dx on this side. So I'll write dy equals to cos x dx. Now integrate, right? Yes, no, that's how we solve it. I think you got this result by yourself so far. So this is what simply sin x, okay, plus c. This is indefinite integral, so constant of integration will come. So this is called as my solution of differential equation. This is the general solution. Okay, how come general solution, sir? Because it consists of a constant, bacha. It consists of a constant. What is this constant? So integral constant. So because of this constant, okay, what are you gonna call this to be? It's gonna be called as general solution of differential equation. When you can find exact value for this c, when you can find a exact value of this variable c, right, then what will happen? Then this will become what? Particular solution. I think the name suggests itself. Particular means for just a specific case. That's why particular solution, when the c is a particular value. Okay, when c is a exact value, is not a variable anymore. For that particular case, it will become what? A particular solution of the given differential equation. Otherwise, it will be a general solution of a differential equation. Means by changing the c value, I can have different solutions of the same differential equation. Okay, but if you fix c for one value, it will become a particular solution. So as the heading you see, general and particular solution of differential equation. So I hope you understand what is the solution of the differential equation, how to find it. And second thing, what is a general solution and what is a particular solution. All right, so moving on. So I hope you can see this, right? Everything was visible. Moving on. Question, now the same thing is written here. Let's see. General solution of a differential equation is a relation between the variables. Okay, obviously solution is there, so not involving derivative. I think you know by now. I said no, solutions will not have derivative in it because already integrated it, okay, which contains the same number of arbitrary constant. Think about it, okay, as the order of derivative. So what was the order over here? 1. What's the order over here? Order is 1. Since the order is 1, okay, how many constants you got? Only one constant. Check here, C. Since the order is 1, you will integrate how many times? Only one time. So that's why how many integration constant you will get? Only one integration constant. But if you have order as 2, you will get how many integration constant? 2 integral constants. Okay. So for that reason, they are saying this. It will have the same number of arbitrary constant, means the integration constant, as the order of the differential equation. If the differential equation is having a second order derivative in it, If the differential equation is having the second order derivative in it, then it will have two arbitrary constants. It will have two constants of integration. Is that clear? Any doubt in that? I hope not. Okay, for example, check this equation: y equals to a cos x minus b sin x. Okay, is the general solution of the differential equation this? Okay, what it means, sir? It means, what is the order over here? Please check. What's the order over here? Sir, order is 2. How come, sir? Highest order derivative. Okay, sir, will it satisfy this thing? You can check this equation: y equals to a cos x I have, okay, minus b sin x I have, right or not? Okay, correct. Do one thing, differentiate and put it in this differential equation. First derivative will look at what look like what? Tell me. First derivative, y dash I can write. Y dash will become what? Minus a sin x, right, and minus b cos x. Anything else? Cos will become minus sin will become cos. Okay, so now second derivative, please check. Why second derivative? Because it has second derivative in it, in the differential equation. It will become what? It will become minus a cos x, and what will this be? I'll differentiate. Cos x will become again a minus sign, so minus will become plus. Minus is there, cos will become minus sign, so will become plus, so b sin x. Now in this value, if you add y value, if you add what? If you add in this value plus y, check the y value, what is it? So I'm gonna write it over here, minus a cos x, okay, from here, plus b sin x. What is this? This is my y double dash. Okay, y double dash, have a look. Okay, yes, this is my y double dash. What are they saying? Plus y. Plus y. What is this? The LHS of the differential equation. LHS of the differential equation, right? Now, so this is my y double dash. From here you can see this, minus a cos x plus b sin x. Okay, now plus y I'll do in the next step. I will not write it over here. Okay, so have a look. What is my y value? Same thing, sir. A cos x minus b sin x. Check y value. A cos x minus b sin x. Yes, a cos x minus b sin x. So a cos x minus b sin x. Now you know what's happening over here. Okay, a cos x gone, this and this gone. What is the answer? 0. And which is equal to what? Simply RHS. It means what? The given equation upon differentiation satisfy the differential equation. Okay, it means yes, they are related to each other. Correct, na? So what they're trying to say, if the second order derivative is present in the differential equation, it will have two constants. Check here, the constants are what? The constants are a and b. The constants are a and b. And what type of solution will be this? So this is my differential equation, okay, and this is my solution of differential equation. What type of solution, sir? General solution. What type of solution, sir? General solution, sir. How come general, sir? Because a and b values are not a fixed value. Okay, so what are these? Example of a general solution, sir. Okay, moving on to, I hope this was visible, right? Everything. Okay, moving on to a particular solution. In this case, as I said, this constants will become a specific value. So 3 and 2 you can see. So this will be your homework. Okay, solve and verify. What are you going to verify? The differential equation, that LHS is equals to RHS or not. Okay, and comment. What are you going to comment? Comment, got it right, sir. Comment, got it right, sir. Okay, what is it? So y is given. This is the solution of the what type of solution is this? This is going to be, bacha, my particular solution. Particular solution of what? Of differential equation. Of differential equation, right? So this is for that category, and this is my differential equation over here. So you put the value of y dash and y double dash from the solution in the differential equation. You'll see that LHS and RHS are satisfied. Okay, so this is the homework for you. Please do it from your side. Okay, I hope you can do that. You understand this? Okay, I'm gonna move on to again questions. Okay, so in today's session, this is the concept that I wanted to discuss. Now we'll solve only questions for the next. few minutes, and then wind up the session. Let's see the first question that's coming up. So that y equals to a e power 2x plus b e power minus x is a solution. How are we going to check, sir? So they have given a differential equation to us like this. Okay, y value is given, so solution is given. I have to verify it. Okay, so most of the questions, I think all of the questions we're going to practice will be on this category only. There will be a variety of questions, but we'll see. Okay, so let's see this. First, what is the first step? Find the first derivative. Find the first derivative. So y dash will look like what? A is a constant. I'll keep a outside. E power 2x will remain as it is. E power 2x, and after differentiate 2x, it'll become what? Simply 2. Okay. What is the next thing? Plus b is a constant. I'll keep b as it is. Okay. E power minus x will remain as it is. So e power minus x. And next, what I have to do? Differentiate what? Differentiate minus x. That'll come as simply minus 1. Minus 1. Okay. I'll rewrite it over here to have more space. So y dash will become what? 2a e power 2x minus b times of e power minus x. Any confusion? Correct, no? Because my sign is there, so it will become negative. No problem there. Next, what is that? We need y dash. We need over here. We also need y double dash. Okay. So let's find y double dash. So I have to differentiate again. So I'm going to get ahead and write it like this: 2a e power 2x will remain as it is times what? Another 2, because I have to do 2 for 2x again. Now what about this? Minus sign will come here. I'll write it over here. B times of e power minus x will remain as it is. Again a minus sign will come. Minus 1. Okay. Now please simplify this. You'll get 4a e power 2x plus b e power minus x. Correct? Check. This mass and this mass will become plus again. Okay. Now I'm going to use it in this equation. So I'll put the values that I have got. My value for y double dash is what? 4a e power 2x plus b e power minus x. Okay. Next what? Minus, I'm going to do what? dy by dx is there. So I'm going to put this value over here. 2a e power 2x minus b e power minus x, and what? Minus 2y. So minus 2 times of y. What is y? This condition. So 2 is outside, no? So e 2x plus b e power minus x. Okay. Now have a look. I've taken only LHS part. Okay. This is the only LHS part of differential equation. Okay. Chaliye. Check here. So I have 4 positive over here and minus 2 negative here, minus 2 negative here. I can cancel both of them. Yes or no? Yes. 4a e power 2x, 2a e power 2x, and minus 2a by e power 2x. So both negative. 4 is positive. Getting cancelled. B e power minus x is there. Okay. And over here, if you open this negative sign, this will also become negative. So this will also become positive. Check here. This is positive. This minus and this minus will become positive. So again, what will happen? 2 positive, and this minus will make what? This positive negative. So 2 negative. If you want, I can simplify this. B times of e power minus x. This will become what? Plus b times, and this will become what? Last one, minus 2b e power minus x. Will cancel each other. Okay. So everything will be cancelling each other. Okay. I do not have to write this part. I can erase this. Okay. What is my answer? Simply 0. And is this equal to RHS? Yes. Hence it is verified, no? Hence it is verified. Okay. So we have successfully verified the given solution to be the solution of given differential equation. Okay. Simple question. Very, very simple. Moving on. Chapter is simple only, not very difficult questions will come. Some might be, but the approach will remain same, the method will remain same. We'll see, and again we'll see in the coming sessions some different type of questions as well. Okay, again a very, very simple question. Solution is given like this. This is a differential equation. I hope this is not a doubt anymore. Which is differential equation? Which is the solution? Wherever there is no dy by dx, that's a solution. Wherever you have dy by dx, that's a differential equation. Okay. So find the derivative from here. If you find the derivative from here, what are you going to get? Please check. You'll get y dash equals to c, simply because x will become 1. Okay, c times of 1 I can write, and that's the constant. A by c is the constant, right? So I can write it as 0. So I'm getting what? Y dash is simply what? C. What is y dash? If you know, dy by dx equals to c. Now over here put the RHS value. What is the RHS value? Please check. X dy by dx plus a upon dy by dx. Okay, what is the dy by dx value? Please check. C. It's c. Right here c plus a upon c. What is this becoming? xc, or better cx will write. So cx plus a by c. Does it remind of something? Does it remind you about something? It's simply y, sir. Isn't that simply what? Our LHS. I started from the RHS and reached LHS, means again verified. Okay, simple problem. Moving on. The differential equation which represents the family of curves, okay, y equals to a e power bx, okay, where a and b are arbitrary constants is. Why are they saying family of curves? Why they are not saying only one exponential curve? It's exponential curve, right? E power bx is exponential curve. So why are they saying family of curves? Because by changing the value of a and b, you'll get different exponential function, no? So you'll get like this. So you'll keep getting different values, right? So you'll get different exponential function for that reason. And what type of function you'll get? How will you get the different functions? By changing the values of a and b. That's why this solution, what is this called? This is the solution, right? Solution of what? Differential equation, no? These are the differential equations. We'll pick which is the correct one. But this is the solution. What type of solution is this? This is a general solution. So for a general solution, you cannot have a fixed value, okay, of the constant. So you cannot have a fixed value of the constant. It means that it will represent set of values. So that's why it is saying what? Understand this. That's why it's saying family of curves. It's not one curve. If a and value is fixed, let's say I take both. I take a as 1 and b as 1. For this particular case, what will the function become? It will become y equals to simply e power x. Okay, what will the graph be? Yes, this is my graph. You understand that? Okay, so that's I wanted to explain you this part. If you are, sometimes what happens is, so by reading the question you feel it is difficult and you give up. So I don't want that to happen to you. So that's why I wanted to explain that term to you. How will you solve this question? Steps will remain same, bacha. Find the derivative. See, you have double derivative also present here, so we don't know which is right. So we'll find both the derivatives anyway. Excuse me. To find the first derivative. So a is a constant, keep it as it is. E power bx will be as it is again, and for bx we'll get what? Simply b. Chain rule we are using. So I can simplify this y dash as ab e power bx. Correct? What about y double dash? Y double dash will become what, bacha? It'll be, I have to do this again. So ab will be as it is, e power bx will be as it is, another b will come. So I get what? I get ab squared e power bx y double dash. Y double dash. Any problem over here? I don't think you'll have any, but just have a look. ab square e power bx and ab e power bx. For this, if I will write this as my 1 and this is my 2, because I'm going to use it for reference. Okay, so equation 1 and equation 2. Now let's put it in the first one. Does it look like y dash is square of y? Because if you square y, you're going to get a square. Okay, you're going to if you square y, check here, right hand side. If you square y, you're going to get a square. If you square y dash, you're going to get a square and b square. It means option number A is incorrect. Now check option number B. Y double dash we'll figure out later. Check the RHS. So y dash value we have now already. So check out RHS. Y times of y dash. So multiply this to y times of y dash. So y times of y dash. Constant A is here. constant, a is here, so a into a will become a square, okay, and what, b times of nothing, so simply b is there, okay. Don't have to worry about anything else now, because please check here, for this condition, y times of y dash, you're getting a square b as the constant, okay, a square b as the constant, but in the case of y double dash you have a b square, so option number 2 also is not possible, okay, not possible. So option number 2 is also gone. Let's check option number D once. I feel this should be the answer. Let's check once. So I'm gonna do y dash the whole square. If I do that, what I'm gonna get? Check here. I'm gonna get a square b square. I'm asking you to check option number D. Please have a look. So y dash the whole square, if I'm doing, I'm gonna get what? Please have a look. A square b square, okay, and e power 2bx, correct na? If you do square, it will become multiplication, so power and power will multiply itself, so 2bx I'll get, a square b square, e power 2bx, don't worry about that because it's going to be the same for both the terms. What about this is my RHS, what about this part? What is this? Y dash. What is y? Multiply, okay, y dash, you're going to get what? Please check. You're going to get a square, okay, this should be y double dash, there's a mistake in the option, this should be y double dash, okay, now you check, there's a correction over here, it should be y double dash, okay. Now please multiply this a with this a, you're going to get what? A square, okay. Now b is not there, so you're going to get what? Simply b square, okay. And what you're going to get now? E power bx is there, e power bx is, you're going to get what? E power 2bx. Check, this is coming right? Yes, this is coming right, no? A square b square e power 2bx. So option number D is correct. So my mistake, I missed one of the double dash value over here. How I got to know? Because see, if there was a y dash over here, no, it'll cancel each other. Think about it. I have a y dash over here, I have a y dash square over here. I can simply write this as y equal to y dash, no? If it is, let's say y dash equals to y dash square, I can cancel this, no? Simply it will become what? Y equal to y dash, correct? So that's why it's a mistake, okay, it's a mistake, so it will be y double dash. Option number D is the correct answer, okay. So I'll write it in the white color only, it's y double dash, okay. I hope this is visible. Y double dash equals to y dash the whole square. Option A, B, C are incorrect. Option A, B, C are incorrect, okay. Moving on, okay. I hope this is simple. Question was simple only, okay. We had to find the y dash and y double dash value and use it in the options here to check, okay. We had to check the option, there's no other way out. So I hope you understood that question. Now moving on, this is a good problem, okay. A differential equation whose solution is, again solution is given with the terms of variables, so it will be a general solution, constant, okay. A is a constant. What is the constant? A is given a constant. We have to pick which is the correct condition, okay. So how do we do that? If you check the question, it requires second derivative and first derivative, so we'll do that first. Let's do that part first. I'll just find the derivative over here, I'm going to use it in the next slides. So let's find the first derivative. I'm going to do what? I have to use, this is not an explicit function, this is not a explicit function, it is an implicit function. What is that? I hope you not forgot, okay, you've not forgotten that part. Explicit function is a function where y is simply given, means y is the subject and rest all things in terms of x is given on the RHS side. But implicit function are the function where you cannot separate x and y, okay, you have to deal with it like that, okay. So we can do it over here. So if I differentiate, I'm going to get what? 2 times of x minus h. I have taught this to you, don't forget, I have taught this to you, differentiation of implicit functions, okay, in the continuity and differentiability. Please go check out the videos in the playlist, okay, it's available, okay. It will be towards the end of the sessions, towards the end of the chapter, okay. So 2 times of x minus h, we have to apply the chain rule. For x I'll do now because h is a constant, so I'm going to get what? Simply 1, okay. Next what? Over here I'm going to do what? 2 times of y minus k. For y I will do now, for y I'm going to get what? y1. Think about it, derivative of y will be what? I did for x, I got 1, for derivative of y will be what? dy by dx, that's simply y1, okay. And what is the constant derivative? 0. No problem over here, okay. Now I'll write this as my equation number 1, I'll do the derivative again because I want to find the second derivative value. So let's find this value from here. Okay, if I do that, first of all, I can cancel this 2, no? Please have a look. I can cancel this 2. This 2 and this 2 will be taken on that side, will become 0, right? I can take this 2 common and take on the other side. 0 by 2 will be what? 0. Yes? 2 and 2 will be taken common, divide on the 0 side. So 0 by 2 will be 0 only. So I've taken out 2, okay? I hope there's no confusion about that. Second order derivative, if you take that, for only x minus h is left, so minus h will be 0. For x will become what? Simply 1, okay? Moving on, what's the derivative of this? This is a question of product rule now, because y minus k and y1, both variables has to be done separately using product rule. So let's say I'm going to keep y minus k as it is. I'm going to do for what? y1. So what I'm going to get? Simply, sir, y2. Yes? Confusion? If you take differentiation of this, what's the answer? Derivative of the first derivative is what? Second derivative, no? Confusion? Derivative of first derivative is second derivative. This is first derivative, y1. What is this? Second derivative, okay? No confusion whatsoever. I'll erase this. Okay, now moving on. Have a look. So I kept y minus k as it is. I did for y1. Now in the other case, I'll keep y1 as it is, and I'll do for y minus k. For k will be 0. For y I'll get what? Again a y1. Please see. For y I'll get a y1. For k I'll get a 0. So I'll write it as simply y1. RHS is 0, so keep it as 0. Now see one thing. So I want to find the value of y minus k. I'll tell you why. Because please see here. Y minus k is present over here. Why that place, sir? Because stick the RHS, a square. Why that, sir? Because everywhere there is a square in the option. It means I have to make use of somewhere the original given solution. Okay, so for that given equation of the general equation, so for the given general solution, I have to find the value of x minus h and y minus k. So if you see here, I am getting y minus k. So I can somehow get y minus k in terms of the derivatives. So I'm going to make use of this equation to find my derivative. No problem here. So please check. I can write this as y minus k times y2 equals to what? Equals to minus sign minus 1 and minus y1 square. No confusion, please see. y1 into y1 is y1 square. Okay, so y1 square. Both are minus sign, I can take minus common. So I can write this as y minus k is equals to minus sign outside 1 plus y1 square, okay, by y2. What is y1 and y2? y1 is the first order derivative, y2 is the second order derivative. Let me rewrite this part again. Okay, moving on. So this is my y minus k value. Now I have to find what? X minus h value also. So I can simply put this value over here in the first equation. I'll get the x minus h value. So I can rewrite my x minus h first equation. X minus h plus I have y minus k times of y1 equal to 0. Have a look. X minus h plus y minus k times y1 equal to 0. 2 and 2 is cancelled. Now what is y minus k value? Y minus k value, I'll put it over here. So x minus h plus, what is my y minus k value? Minus sign 1 plus y1 the whole square by y2 times y1 outside equal to 0. I want to find my x minus h value. Okay, now please have a look. Okay, 1 second. I'm going to create a separation. Okay, have a look now over here. So I can write the x minus h value over here as x minus h equals to, I'll bring hold of this on the other side. It will become what? Minus will become positive, so it will become plus 1 plus y1 the whole square times y1 upon y2. Please check. Whole thing is moved on the other side. So everything is same, just the sign minus becomes plus. Nothing is different. Okay. All right. So I don't need this anyway. So I'll write it like this. Now please check. I'll use my original equation, which was given by x minus h the whole square plus y minus k the whole square equals to a square from the first one. okay, from the general solution. Now y minus k value, I know this is this value y minus k. I'll put it here. X minus h value also I know, so I'll write it here, 1 plus y1 the square. Now this is x minus h value. Do I need that? I need whole square of that. Okay, so I'll do this. So I'll write it as the whole square. Okay, and then y1 is outside, so I'll write it as y1 the whole square divided by whatever is in the denominator, that also will be squared, so y2 the whole square, y2 the whole square, plus there's a negative sign over here in the y minus k value. Please check, negative sign, but if you square it up, it will become what? Positive. So I will not consider the negative sign. So I'll simply write what for this thing? For y minus k, I'll write it as 1 plus y1 square. I hope there's no confusion whatsoever. Okay, bacha, 1 plus y1 whole square, the whole square. This y1 is also, no, this y1 is not there in that case. Okay, I don't think it's there, is it? Please cross check, we'll cross check, don't worry about it. So y2 the square equals to a square. Is the y1 there outside? No, there is no y1 outside. Okay, so only minus sign was there, minus becomes positive, and this 1 plus y1 the whole square becomes whole square from outside also, and the denominator become what? Y2 the square. Please check. Okay, now I can take something common, right? I can take this 1 plus y1 square by y2 square common. So okay, about before that, I can take the LCM also, right? Take the LCM and bring it on the other side. So since it is same, the denominator is same, what will this become? 1 plus y1 square times y1 square. Okay, there's a whole square over here, I forgot. Please check, whole square over here, too many squares, so that's why the confusion. 1 plus y1 square the whole square. How whole square? Because we are looking for x minus h the whole square and y minus k the whole square. That's why so many whole squares coming. Now I'm getting what here? I'm getting this as common denominator, okay, equals to a square. Am I right? Now can I move this on this side? Please check. I can take this by cross multiplication, so I'll write it over here and erase from this side. Okay, now I'm gonna erase this over here. Okay, chali. Now last step, I'll write in the next slide, but I'll repeat this step again. 1 plus what I've got so far, 1 plus y1 square the whole square, y1 square plus 1 plus y1 square the whole square equals to a square y2 square. Am I right? Yes. Okay, now I can take something common, bacha, from here. 1 plus y1 square the whole square. I'm taking this part common. I know this looks complicated, but it is not that complicated. Okay, agree with me, it's not complicated. Simple steps, but just, you know, lengthier. It's just lengthier, not complicated. Just take it common. 1 plus y1 square the whole square. I'm taking common, bacha. I'm taking the whole square common. What is left in the first term? y1 square plus 1 equals to a square y2 square. Okay, now please check, it's the same thing, right? 1 plus y1 square the whole square, and what is this? 1 plus y1 square. Okay, please check. What is this? 1 plus y1 square the whole square, and what is this? 1 plus y1 square. If I write this as, if you can't see it right now, what is this? This is A, this is B, this is A, this is B. So basically it is A plus B the whole square and times A plus B. It will become what? Simply A plus B the whole cube. So what I'm saying is, it is a plus b the whole square multiplied with a plus b. It will become what? A plus b the whole cube, na? Base is same, power will be added, right? Correct? So from here I can write it as 1 plus y1 square the whole cube equals to a square y2 square. Yes or no? Now write the values of this. So I can write this as 1 will remain as it is. What is y1 square? So dy by dx. y1 is what? dy by dx the whole square, the whole thing to power 3. Check here, 1 plus y1 square the whole cube. What is this? A square is the constant, a square. What is y2? So second derivative, d2y by dx2 the square. This is my final answer. Let's check which option is correct. Okay, which option is correct? Okay, any option like this? Option number B looks right. Correct. See, 1 plus y1 square the cube, a square y2 square. Okay, a square y2, or d square by y dx square, the whole square is also there. In the first one there is no whole square, that's why option B is correct. In the third one there is no square for the y1 side, so option number B is correct. Let me erase this constants. Okay, this marks. Option number B is correct. So I'll show from the beginning. Okay, I hope this is visible. Moving on, and this slide also. Okay, you want me to show you backwards? So this is my final answer. Yes. Okay. Question number 8. The differential equation whose solution represents the family. Okay, the family is given, sir. Good. Okay, now please check, they're asking the derivative. Okay, we have to find differential equations, we have to do the derivative. So today we are dealing with derivative. Next class we'll talk about integrals. Okay, we'll see that in the next class. Today let's talk about the derivative. So what is it? It's going to be xy equals to, okay, so I have to find second derivative. Correct, no? I have to use the product rule, but I'll use it, no problem whatsoever. I have to find second derivative, I have to find first derivative. Let's do that right away. जल्दी से कर लेते हैं, कुछ कठिन बात है ही नहीं. क्या है भाई? xy is there. I'll write it over here because I just need to use for product rule. A e power ax plus b e power minus ax. First derivative will look like what? Again, it's a implicit function. I can write it like this. Put here, I'm going to keep x as it is. It'll become what? y1. Please bear with me. X as it is, the differentiation of y is y1. Next, plus sign because of the product rule. I'll take y, I keep y as it is. Differentiation of x is what? Simply 1. Yes. Okay. This will become a e power ax. And what about e power ax? So e power x is e power ax. What about ax? So a, and this will become what? Plus b will be as it is, e power minus ax will remain as it is, and this will become what? Minus a. है ना? Because minus ax will become what? Minus a after differentiation. So can I do the second order right away? Okay, we'll see, but I need the value of y1, I think. Do I need the value of y1? No, I don't. Let's just see this. Well, we'll just simplify this anyway. So xy1 plus y equals to a small a e power ax minus b small a e power minus ax. Okay, my equation number 1. Okay, now equation number 2 will be what? Second order derivative. Okay, so let's just find it over here. Can I do this? I can do this again. Second order derivative from here. It'll become what? I have to do the product rule again for xy. So I'll just use this space. Okay, sir. So it'll become what? X will be, I'll keep x as it is. It'll become what? y1 will be becoming what? y2. I hope you agree. No? Please check. Please check. y1 derivative of the first derivative is what? Second derivative. So y1 will become what? y2, because I'm keeping x as it is for the product rule. I'll put a minus plus sign because of the product rule. I'll keep y1 as it is, and I'll do for x, I'll get what? 1 again. I've done only for this part, first term. Okay, for the second one, y, I have what? I have here y derivative will be what? Simply y1. Then the equal to sign will come. I'll do the derivative of the RHS part again. Please have a look. Okay, so a, capital A small a is there. I'll get e power ax differentiation as e power ax. No problem whatsoever. For ax I will get another a. Okay, I'll proceed to the next step. Minus sign will be like that. I'll keep b and a, the constants, as it is. E power ax remains as it is, and for after differentiation, and e power minus ax will be giving me after differentiation simply minus a. Correct, bacha? Okay, now please simplify this left hand side. I am getting xy2 is there, right? I write it as x d square y upon dx square. Why, sir? Because the question is given in that term, options, for no reason. I can write it as y2 also, no problem whatsoever. Okay, what about y1 plus y1? Sir, 2y1. y1 plus y1, 2y1. What is y1? 2 dy by dx, है ना? y1 plus y1, 2y1. And what is y1? dy by dx. Okay, आगे बढ़े. Now please check here. I have a square, I have a into a, again a square. Please check. I'll use some other color to show you. A into a into a. So a square is there, I can take a square common. Okay. Now what is left in the bracket? Please check. A is left, so capital A, e power ax is left. That's all in the first term. Second term, minus sign is there, there is another minus sign. Check here. Minus sign and minus sign. So plus sign. Okay. What about this? So b is left, sir, because a square you already taken common, sir. So b is left. And what is this? E power minus ax, sir. E power minus ax, sir. Okay. So चलो कर लेते हैं. A square, what is this? A e power ax and b e power minus x. Sir, looks familiar, sir. Yes. This is my xy value. So right here, xy. Right here, xy. Okay. Now which option will suit now? Please check. X d square y upon dx square plus 2 dy by dx a square xy. Option B है बचवा. Option B है correct option. Yes, we started from here. These are my steps. Step 1, step 2, step 3 and step 4, step 5. Okay, I should have used the next slide, but I got it done over here only. No need. Okay, हो गया. Done. Done as a easy question. Very easy. Okay. All right. Can you see this? I hope you can see this. Moving on. Find the differential equation whose solution are given in the question. Okay. Following question like this: c plus 4yx. Okay. So do I need y2? I don't need y2. Check here. Only y1 is there. Means only first derivative is there everywhere, sir. So do the differentiation only once. So check this function: c plus 4yx equals to 0 is there. Differentiate, you're gonna get 0 for c. You're gonna get, have to use the what? Product rule over here. So keep the constant outside. Product rule, sir. Yx is there, sir. Yx means what? You have to do it one variable at a time. So keep the constant outside. 4 is outside. For y, I'll keep y outside. X will become what? Simply 1. And I'll put a plus sign for the product rule. And I'll keep x as it is. For y will become what? Simply y1. Okay, equals to 0. And now since this is a constant 4, I can take it on that side. It will become what? Simply y plus xy1 equals to 0 by 4. That's nothing but 0 only. Okay, so I get what? Any option like this? xy1 plus y. Arey, option number B, right? So I can write it in that way. xy1 plus y equals to 0. My final answer in 3 steps. Simple problem. Question number B is correct answer. Enjoy, Madi. Enjoy. Okay, full enjoy, Madi, sir. Moving on. Question number 9. Simple, done. हो गया. आगे बढ़े. Find the differential equation whose solutions are given in the following question. Okay. This is general form of the general solution of the given differential equation. The differential equation is not given, the general solution is given, sir. Okay, fine, sir. Let's solve it, sir. Do I have, okay, I have to find the y1, I have to find the first derivative, that's all right. But do I need to find y2 also? I don't think so. There's no y2, this y square is there. I don't have y2, so I don't have to find the second order derivative. I have to only find the differentiation only once, sir. Differentiation has to be done only once. What can I do? I can do it directly also. But if you check here, I have a square term here present. Because if you take a minus b the whole square, you're gonna get this term the square as well, which is on the right hand side also. Will cancel each other, right? So let's see what we can do. What can we do, sir? So x square plus y square plus a square minus 2ay equals to 0. No, not the differentiation, only a square. No, I have not taken differentiation, though I can cancel this and this. It'll become what? Please tell me. It'll become x square plus y square minus 2ay equals to 0. Yes, so I can write this as what? Okay, so I can write this as x square plus y square equals to 2ay. Okay, so this will become what, bacha? This will become x square plus y square upon y equal to 2a, equal to 2a. Yes, now I can differentiate it. Correct? Please check. I have taken the variable on one side and constant on one side. Let's see the differentiation. I have to use what? I have to use the quotient rule here, sir. So I'm going to keep this as it is, x square plus, so okay. I have to not keep this as it is, I have to keep the denominator as it is in the first term, no? So I'll keep y as it is. I'm using the quotient rule. I'll keep y as it is. I'm doing for the numerator part. It will become simply 2x for the first term. Second term will become what? 2y y1. For y square I have 2y, then I have to do for y also for the chain rule. So y1. Then next what I'm going to do? Keep a minus sign and keep this whole thing as it is, x square plus y square as it is, and do for the y. I'm going to get what? y1 upon what? Upon y square, and this whole thing is equal to what? 2a differentiation. So how much is that? 0. How much is that? 0. Okay, now cross multiply. What are you going to get? Please check. You're going to get 2xy, okay, 2xy plus 2y square y1, okay, minus x square y1, okay, and minus y square y1 equals to 0. How come, sir? I can take this y square on this side, no? It will become y square into 0, so that will be 0. So the denominator is gone. Okay, only I have expanded the numerator. So I'll write this over here, 2xy plus 2y square y1 minus x square y1 and minus y square y1, I think, equals to 0. Have a look. Yes, I can simplify this. This is 2y square and this is y square. So I can write it as 2xy minus x square y1 and plus y square y1 equals to 0. Any option like this? Please check. Any option like this? X square is there. No, I have to differentiate that. Okay, so I'll put the negative stuff on one side and positive things on other side. So this is only negative term. I'll bring it over here. It'll become what? 2xy plus y square y1 equals to x square y1. Okay, I'll bring the y1 over here. So 2xy upon y1 plus y square y1 upon y1 equals to x square. Okay, this cancels each other. What I'm gonna get? 2xy upon y1 plus y square equals to x square. Is any option like this correct? Please check. X square y square 2xy upon y1, x square y square. So this is correct. Which option is correct, bacha? Option number B is correct. Okay, yeah, so I was thinking which to take on what side. Okay, so I first thought of making y as a subject, but then I realized we'll just complicate the work. So then I took constant on one side because I can see the equal to signs are there. It means that one side, if I make it 0, no, it'll be easier to calculate from there onwards. That's why I was just thinking there what to do. Then I brought this y over here and got this result as x square equals to y square plus 2xy upon y1. Have a look. I hope this is visible completely. From here we started. This is my first step, second step, third step, fourth step, fifth step, sixth step, and moving on over here like this. My final step. Okay, visible. Okay, moving on to the last few questions that we have. E power minus 2x, I have to differentiate. Okay, 2 times bacha. second order derivative is present here, so 2 times will do. Let's do it. 2 times differentiation. I think you can do this, no? Can you not do this? I'll tell you what. Y is given, no? Y equals to e power minus 2x is given, okay? And what is it? Tell me. So I have to find y double dash, y dash. What I'm gonna get? Minus 2 e power minus 2x, okay? E power minus 2x, okay? Okay? E power minus 2x. What is my y double dash? Tell me. So plus 4 e power minus 2x. How come, sir? If you differentiate, no, 2 will remain as it is, minus 2, and if you differentiate, e power minus 2x will remain as it is. Then if you do minus 2x, you're going to get again another minus 2, right now. If you do minus 2x, you're going to get another minus 2. That will multiply with minus 2 for the first one, will become plus 4. Do the differentiation, okay? Perform differentiation, okay? This question I'm leaving it to you, but I want to know what is the answer. So y double dash is 4 e power minus 2x. Y dash is this. So yeah, I think option number A is correct. Sorry, B is correct. Please check if this is the case. So plus 4 for this case, okay? Now this is already negative, so negative of minus 2, and this will become again minus 2. So yeah, plus B. I think this is B is correct answer. So do one thing. Solve and comment your answer for question number 11. Either B or D option is to be true. I have not solved it truthfully, but I think B is true. Okay, I've given the option as B, no? So B is true. Do the differentiation, solve this question and comment the answer. All right, चलिए आगे बढ़े. Question number 12.
एक पॉज कर दो ना, 2 मिनट के लिए ऊपर आ जाना.
सर लास्ट क्वेश्चन है बस ये, खत्म. लास्ट 12th लास्ट है. Okay, so question number 12. Y equals to a cos x plus b sin x is a particular solution of a differential equation. Okay, कर लेंगे, right? Simple problem. I have to find second derivative, बच्चा. I have to find the second derivative, no problem. So how will you find second derivative? Please check. Y is given as a cos x plus b sin x plus b sin x. Find y dash. Find the y dash, okay? So y dash will be what? Y dash will be a minus sin x, okay, plus b cos x. Am I right? Yes. Now what will this become? Tell me. For y double dash, I'll have y double dash as, so this is going to be a is already a constant, minus will be outside. For sin x will become what? Cos x, because minus is already there. I did only for sin x. What about this? B will be as it is. For cos x I'll get what? Minus sin x. So please write it over here. Okay, so what if I simplify this? Y double dash is going to be minus a cos x and minus b sin x. And what is going to be my y dash? Minus a sin x plus b cos x. So please check which one is correct. Can we check the first one, A option? So minus a cos x, okay, minus b sin x, okay. This is my y double dash. I'm taking the LHS over here for the first option. What is this? Y double dash minus y. Y double dash minus y. I hope this is visible. Yes. So this is y double dash value minus y. If I'm doing, I'll do what? A cos x and plus b sin x, okay. B sin x will become what? Minus, okay, it'll be plus 1, okay, it'll be plus 1, so it'll not be a minus 1. My mistake, it should be a plus 1. So option number C we will take. Option number C, this is going to be plus 1, okay. So if I do that, what I'm going to get? Please check. So a cos x minus b sin x plus a cos x plus b sin x, okay. Please have a look. Gone. What is the answer? 0, which is RHS. So my correct answer is what? Correct answer is option number C. Okay. So again, this is also your homework. Okay, I've done the solution, but I've done it quickly. Okay, because this is not a difficult question, no. This is not a difficult question. A simple problem If you are not able to understand, if I did it faster, please do it again. Okay, please do it again, sir. Okay, all right, so please do it again. I've done the y dash and y double dash. Option number C is correct. Option number C is correct, bacha. Okay, so this completes our first part of, I hope this is visible right from the beginning. Yes, everything is visible. So this completes the first part of our differential equations. Yes, differential equations part 1 is done, where we talked about general solution of differential equation. We talked about general solution of differential equation. We talked about particular solution and some basic definitions we talked about. Okay, and we solved good amount of question. Okay, there were some good questions also, and mostly the questions were easier. The chapter is like that. Okay, some questions will be challenging, but that is okay. Apart from that, if you know the differentiation, if you know the integration, the chapter is nothing. Okay, it's very, very simple chapter. So I hope you can solve all the questions with me only in the session. So this completes the session. I really wish that you are working hard with me. Okay, so keep working hard, bacha. I'll keep seeing you in all these sessions. Okay, next again I'll do the part 2 of the differential equation in the next class. So be prepared. Okay, revise these previous topics. I hope you are not lagging in the revision. Okay, so keep working hard. I'll see you in the next session. Till then, take care. Bye bye.